Welcome to Term 3, Technology Grade 7, and we are starting with Unit number 5 on page 114 of your textbook. And we are going to look at different investigation skills. After you have completed this unit, you must be able to demonstrate your knowledge and understanding of 1. Magnetism. And under magnetism, you must know the type of magnets. Okay? And you must be able to investigate magnetism. And you must also know or understand recycling. Let's go through the introduction. In this unit, we will discuss magnetism and learn about magnetic fields and different magnetic objects. Okay, so we'll discuss magnetism, we'll learn about magnetic fields and different magnetic fields objects. All magnets have a north pole. Okay, north pole, and this is a north pole, and a south pole, as well as magnetic field. So this is a north pole, this is a south pole, and these lines that you see here, they represent magnetic field. Okay, so north pole, south pole, and magnetic field. The magnetic field is the space near the magnet, and it consists of invisible field lines that always travel from north to south. This is a magnet, and the magnetic field traveling from north. You see this arrow shows you that this comes from north to the south on the magnet. So the magnetic field lines are always traveling from north to south on a magnet. The earth is a large natural magnet. So the earth is also a magnet. It has the magnetic field running from the geographic North Pole to the geographic South Pole. And they explain to us what does geographic means. Geographic means as indicated on the map. Okay. So, as opposite poles attract each other, the Earth's magnetic South Pole is underneath the North Pole at the top. Okay, so the south is at the bottom and the north is at the top. And the magnetic pole is underneath the south pole at the bottom. This is on the magnet. Here it's on the earth. The north is at the top, the south is at the bottom. But on the magnetic south pole, the south is at the top and the north is at the bottom. Now we look on the next page, page 115, and we see there is important terminology. So we have to look at all these terms and study them and know them for any exam, test, or assignment if they want the description. So please, page 115, go. All these terms that are here, you must study them and know them. Okay. I won't go through it. This you can do it as a self-study. So now let's look at magnetism, lesson 14 on page 116. Magnetism is a physical phenomenon exhibited by a magnetic field. A magnet has two poles, namely a north pole, which is positive. Please note, north pole is positive and a south pole is negative. So a magnet has two poles, a north pole that is positive and a south pole that is negative. A magnetic field forms around a magnet and moves in a determined direction from the north pole to the south pole. Okay. So they say a magnetic field forms around a magnet and moves in a direction from the North Pole to the South Pole. These lines that you see here, they are magnetic field, okay? And you can see they move from North Pole to South Pole. They move from north to south. Move from north, you can see the arrow, they are going to south. You can see they start from north, they are going to south. And they start from north, they're going out. They're going out, you see. Now, where are we? To the south pole of the magnet. Magnets either attract or repel other objects with magnetic properties. So they don't attract or repel anything. They only attract or repel objects with magnetic properties. Okay. So look, we have this North Pole, it's another magnet, and we have the South Pole on another magnet. So you see magnetic field is moving from north to south, from north to south, from north to south, and they come close to each other, which means they attract each other because they are opposite. And we have two magnets which are facing each other on the North Pole. You can see they repel each other, they are pushing each other. So you see the magnetic field lines are not crossing. It shows that the magnets are repelling each other. Okay, let's read. If we place two like, which means they have positive and positive, or they have negative and negative, like this one, they are like poles of two magnets together. They will push, which we call repel, each other away because both magnets have the same polarity. Why are they repelling? Because they have the same polarity. If we place the two unlike, which are not the same, the positive and the negative poles of two magnets together, they will pull or attract to each other because they have different polarity. Okay, so magnets, like magnets or like charges, they attract each other. And sorry, the like, these are the likes, they will repel each other, and the unlike will attract each other. Now let's look at different types of magnets. Magnets can either be permanent or temporary magnets. Permanent magnets, as indicated by the name, have a permanent magnetic field and keep their magnetism for a long time, e.g. a bar magnet. Okay. And then temporary magnets, they don't have permanent magnetic field and they only become magnetic in the presence of a permanent magnet. An electromagnet is an example of a temporary magnet. Please note that you must know the definition and the example. Electromagnet is an example of the temporary magnet. As long as there is electric current flowing through the magnet, it has a magnetic field. As long as there is electric current flowing through the magnet, it has the magnetic field. As soon as the current is turned off, the magnetic field disappears. So for magnets to have a magnetic field, the current must be flowing. If no current is flowing, then the magnetic field disappears. Lesson number 15, we will investigate magnetism in different scenarios. But before we do that, they tell us that all materials are either magnetic or non-magnetic, and only certain types of materials attract to magnets. Magnets attract the ion components in certain materials. And then ferrous metals, this is one of the words that is in the terminology, are magnetic and contain ion. Ferrous metals, which are ferrite, are magnetic and contain ion, while non-ferrous which is non-ferrite metals, do not contain iron. Magnets only work with ferrous metal, which contains iron.